All right, we're looking at rational exponents. So remember, what are rational numbers? These are numbers that can be written as a fraction. So we can put them into a fraction. And yes, that means they're not are repeating or terminating decimals, but really this is our definition. So what are rational exponents? Well, they are fractional exponents. So that's what we're dealing with. So all we're doing with when we have rational exponents is we're changing. So if we have a to the n over d, we move our denominator of the fraction of our exponent to be the index and the n to be our exponent. It can be inside or outside the radical. So you just rewrite it. And that's all we're doing. We're not even simplifying now. So let's try these 6. See what we can figure out here. So 10x to the 2/3. Well, that 2/3 is only on the x, not on the 10. So 10 stays the way it is. Then we're going to have a radical. X is in the radical. And the 3 becomes the index. And the 2 becomes the exponent. And again, you can write it like that as well. But just the x has that because that's there. The exponent on 10 is really 1. All right, number 30. Now both of them are going to be in the radical because we have parentheses. We have parentheses, 30m. My index is 2, and I don't have to write that. And then 5 is our exponent. And I would keep it there, not inside, because then you'd have to write it in parentheses still, so just keep it on the outside. The next one, well, we have 3 things, but they all have the same denominator. So they all have the same index of 5. And then we have 5 cubed, a to the first, and b to the 4th. So put them all in there together. Slightly simpler one, cube root of 45x. Now we're going the other way around. So 45x have both the exponents because it's in the radical. So 3 is my index, and it becomes my denominator. And I don't have any exponents, so really it's 1, so it's 1/3. So the cube root of something is anything to the 1/3 power. If we look at this next one, again, 10's not inside of it. 10's by itself, and then we have parentheses. Actually, we don't need parentheses for this one. So it's m, and 4 is the exponent, the numerator, and 7 is the index. The last one up here, well, they all have 6 as an index, so they're all going to have 6 in the denominator. So a to the 7 over 6, b to the 5 over 6, c to the 10 over 6. So it's just the opposite of the problem above it, basically. All right, so now we have some others. You're going to do these in class, but we can go over them quickly. 4, and then the 9th root of d to the first power. We don't need to write to the first power. Number 2, both of them are inside. 3 is our index, 5 is our exponent. Number 3, we're going to have one index, or an index of 8, because they all have the same, and then 8 x squared y cubed. Now, switching it to fractional exponents or rational exponents, 19, because it's fine, it has an exponent of 1, but d is going to be 5 over 3. The index becomes the denominator. Here, both of them are in it, so 36 a to the 5th and that's all to the 1/3. Or if you want to put them separately, 36 is to the 1/3, because the exponent on 36 is 1, and then a would be 5/3. I think this one's probably a best bet. Then number 6, they all have the same denominator of 7, so that's our index. And then we have 8 cubed, x to the 5th, y to the 3rd, and z. And that's our rational exponents.